Hey ICP students, today we're going to be talking about how to go about creating graphs for motion. Okay, this is from last week's calculating speed assignment. I'm going to make a graph real quick in Google Sheets. So I click new, I highlight my data, I copy it, I open a new spreadsheet. Once the spreadsheet loads, I paste my data in, I highlight just the data and the columns. I'm going to hit Insert, Chart. It thinks for a minute, and then this creates a nice scatter chart for me. A lot of times I like scatter charts, but I also like line graphs. I'm going to have us set this one up as a line graph. I'm going to customize it, and I'm going to add in on the series, I want to add in points. Now it has the dots and the lines, and I really like that for this graph. I also can go in and change the chart title. We're going to say distance the 3 cars traveled. I can also change where that's located, put it in the middle. I notice I don't have a vertical axis title. On the vertical axis we need to put something there, so I'm going to say distance in meters. And so now if I look at my graph, if we look at the graph, we can see it takes up, we got distance on the vertical axis, time on the horizontal axis. Looking at my cars, I got car 1 was traveling, it traveled about 80 something kilometers in a little about hour and a quarter, or sorry, 80 something meters in about 1 or 2 seconds. Okay, and then that's the fastest car because it has the steepest slope. The red car is slower. And then this yellow car is going slow at first, but then it starts to speed up. And at the last section, it's going the fastest. Okay, so the red and blue cars have constant velocities. The yellow car or orange car has an increasing velocity the longer it goes. Okay, so that's how to use graphs in Google Sheets. We also did the speedy journey assignment, and I'm going to put in the data real quick. So I got all my data in. Now to make labels in this, I have to click on the little wrench at the top. I like to use projector mode because you guys can see it a little better. On the horizontal axis we have time, this time it's in hours. And over here we have distance in kilometers. And this is 2 objects traveling. And I can change the slope of this, and I can find out the equation of this line. That right there shows what's going on with the first car. Second car is like that at first, purple line at first, and then the second half of it, it's the red line. And as I look at this, I get an equation, y equals mx plus b. Okay, m is the slope. And as we said before, the slope is the speed. B is the starting point. Okay, so one of them started at 20 kilometers, the other started at 0. And then we get both of their slopes in there. We're going to use this when we do the train problems. So the newest assignment this week is we're working on train problems. Okay, so go ahead and read over the problem, and then we'll do the first one. I'll do an example. Okay, for each problem we're going to make the first one red, the second one black. We're going to click on this link to Desmos and we'll pull up this graph over here. I'm going to turn on projector mode. We got time and position, and looking at we have to answer 4 questions based on the setup. What position do they meet at? When do they meet? What time is it? What distance did train 1 travel, and what's the displacement of train 2? We always need to use these settings for all of our graphs. If you use these settings on the projector, then you'll be able to get all the information. And by what I mean by is, I come over here on the x-axis, I always want to plug in -5 and 20. If I zoom out, it's going to change stuff. We don't really want to do that. We want to always have this one at -5 and 20. On the y-axis, it says we need to have at -400 and 750. So -400 and 750. For the first set, I'm going to have train 1 start at -100. That's my initial starting position. And the speed is 22.5 kilometers per hour. So I need to plug in the speed to be 22.5. And it starts at -100. So this would be the map, or the route of train 1. Train 2 starts at 600 kilometers, but it's going at -45 because it's going in reverse. -45, and it starts at a position of 600. Now, as I look at them, I can see that both cars are not or trains are going different directions because the slopes are different. I see the first one started at 0 time and -100 kilometers. The other one started at +600. And I got this little dot over here, which is 10.37133. That's when they're at the exact same position. So 10 hours and 10.37 hours after they leave, they're going to be at the location of 133. So on here, the first question is, what position do they meet? That's 133. How long does it take them to get there? 10.37 hours. And then the third question's, what is the distance that train 1 traveled? Well, looking over here, I ended at 133, but I started at -100. So I went up 233. The last question says, what's the displacement for this one? Displacement is always final position minus initial position. So in this case, it's -133 minus 600. Nope. Sorry, final position is +133. So 133 minus 600 gives me a displacement of -467, which is right there. Okay? So for this assignment, the train assignment, you're going to do 6 of the problems. The first 5 are all the same. The second 5, they're more difficult because they don't always start at the same time. So on this one of them starts at 12, the other one starts at 2 hours later. So you have to change a little bit as far as where they're going. Okay, so this has been an introduction to position time graphs. Again, the slope tells you the speed. The vertical intercept tells you the starting location. And when the two lines cross, that's when they meet and where they meet. Okay, good luck this week.